So, dear students, in the previous videos, we see about the operational procedures in the PLC. So, in this video, we want to see the some examples related to the contacts and coils. So, in this video, we discuss the 6 examples. So, what are those 6 examples? Means first one is the simple one example explains simple one contact and one coil circuit. And the second example is standard start stop seal circuit. And third example is forward, reverse and stop with mutual interlocks. And example 4 is forward, reverse, stop with direct reversals. And example 5 is start stop jog. And example 6 is alarm system. So coming to the first example, so this is a simple example. That means when the switch is on, when the switch is on, then the motor will be run. When the switch is on, then the motor will be on is the first example. So for that, what is the ladder diagram? Means, so the switch can be, here is the input device. So this input device can be represented with the definitely contacts. So that contact can be represented as IN001, and the motor running can be represented with the output CR017. And this diagram, connection diagram, represents the how that will be applied to the PLC. So this program will be present in the PLC CPU. So the PLC CPU, one side we have the input module and another side we have the output module. So input devices are connected to the input module and the output devices are connected to the output module. So here the input device is switch, input analog switch, and the output device is motor. So this is about the first example. So coming to the second example, we have standard start stop seal circuit. That means what we do means, if you press the start button, then what happen, the motor will be run. And if you remove the start button also, then also the motor continues is rotating. And when this motor will stop, when we press the stop button, then that motor will be stopped. So this is the example here. So here we have the stop button, that is a normally closed push button switch, and here we have the start button, that is normally open start button, and this one is the auxiliary contact. This auxiliary contact depends upon the output of the motor. So first we press the start button. So if you press the start button, then what happens? We can provide the closed path, so the motor will be run. When the motor will be run, then the auxiliary contact will be active high. So active high means that contact will be acts as a closed contact and provides the path to the motor. So at this case, even though you remove the, that means we off the start button, then also our motor continues to run. And when will this motor will stop? When we press the stop button, then this normally closed push button switch can be becomes as a normally open push button switch, then the motor will be stopped. So this is the elementary diagram or relay logic diagram for this particular example. And the PLC logic diagram is this one. So here the start button represents the one contact. That contact is nothing but IN001, and the stop button can be represented with contact number IN002. So since it is a normally closed push button switch, so that's why we can represent the stop button switch with normally closed contact. So if you press the start button, that means this IN00 is on. So this normally open contact will be become as a on, that means close. So IN002 is closed one and IN001 is closed one. So we can have the path for the CR017. So when the CR017 is on, then this contact, this is seal circuit, this seal contact will be on. When the seal contact, normally opened seal contact is on, then it can be becomes as a closed contact. So the path will be IN002, CR017 and CR017. At this case, even though you remove the IN00 start button, we make the off position, then this will become as a normally open contact. Then also the CR017 output will be present. So with this CR017 output, our motor will be continuously rotating. So in order to stop our motor, what we have to do? We have to on the IN002. That is the stop contact. So when IN002 contact is on, then initially this is a normally closed contact. So when we make it on, then this one can be becomes as a normally open contact. Then there is no path for the CR017. Then the CR017 is the off. So this diagram will be inserted in the PLC CPU. That means present in the PLC CPU, and we can represent the connection diagram. That means PLC CPU and one side input modules and another side output modules. So input devices are connected to the input modules, and the outputs are connected to the output modules. So for input we have start button and stop button. So those buttons are represented here. And for the output we have the motor. So motor we represent here. For the supply for those one we can represent this COM. This COM represents the supply for the input devices and supply for the output devices. So this is the example 2, and the same can be explained with the latch and unlatch circuit also. That means when IN1 is on, then this particular 608 is on. When IN2 is on, then this 608 will be off. So if we start the IN1, then what happened? The 608 is on, so output will be on. So when will this output 7 will be off? When means when the 608 is off, then only output 7 is off. So when this 608 is off, then the IN2 is on. That means stop button is on. Then only the output 7 is off. So the same logic, previous logic only, but that can be represented in two ways. Here is the contact representation. Here this is called latch or unlatch logic. This diagram is called as the alternate latch or unlatch circuit. And coming to the third example. So what is the third example means? If you press the one switch, the motor will run in one direction. That means forward direction. And if you press the another switch, IN003, then the motor will be rotates in the another direction. That direction is nothing but in reverse direction. And here we have one representation. What is that representation means? When the motor will rotating in forward direction, then we won't run the motor in the reverse direction. And in a similar fashion, when the motor is rotated in the reverse direction, then we cannot run the motor in the forward direction. So how means this ladder diagram explains this logic what I told. So IN001 represents the stop contact, and IN002 is the start contact for the forward direction, and IN003 is the start contact for the reverse direction. So first I press the I want to rotate the motor in the forward direction. Then what happens? So in this particular logic, IN001 is normally closed. That means off position. Stop button. This one is the, and I press the IN002 switch is on. So when the IN002 switch is on, that means contact is on. This contact is normally open contact. So when this will be make as on, then this open contact can be acts as a closed contact, and we can have the one closed path here. So already CR18 is there. So this one is the closed contact, and this one is the closed contact, and this one is the closed contact. So we can have the path for the CR017. CR017. When CR017 is on, then this contact is on. So when this contact is on, initially this contact is the normally open contact, and when this contact is on, then this contact can be acts as a normally closed contact. Then even though we remove the stop button for the forward direction, the motor will be rotate in the forward direction but not rotate in the reverse direction. Why? Because when the CR017 is on, the CR017 contact can be represented in the here also. So here is the normally closed contact. So when CR017 is on, then this contact is on. This is normally in closed contact. So when this will be on, what happen? That normally closed contact will be converted into open contact. Then even though we press the IN003, but the CR018 is not on, that means the motor does not rotate in the reverse direction. Why? Because the CR17 is in open contact, so there is no path for the output. There is no path for the output. So the same explanation can be applicable for the reverse direction also. That means first I want to rotate the motor in the reverse direction. So for that what I have to do? I have to close the IN003 contact. I have to close the IN003 contact. So when I start the IN003, then initially it is a open contact. So when I make it on, then it can be acts as a closed contact. So this one is the closed contact, and this one is the closed contact, and this one is the closed contact. So we have to provide one path for the CR018. So when the CR018 is on, then this contact is on. So this contact is normally open contact. So this open contact will be when it making as on, then this can be acts as a normally closed contact. So even though we remove the IN003 contact, but because of this path IN001, CR018, CR17 path, the CR018 is on. So the motor will be rotates in the reverse direction. But at that case, our motor does not rotate in the forward direction. Why? Because here we provide the interlocks. That means when the CR018 is on, then this contact is also on. So this contact is a normally closed contact. So when we make it as on, then this normally closed contact can be acts as a normally open contact. So this will be open. So when this will be open, then there is no path for the CR017. That means when the CR017 contact is on, then CR018 is off. And the CR018 contact is on, then CR017 is off. That means if the motor rotates in the forward direction, that motor does not rotate in the reverse direction. And similarly, if the motor rotates in the reverse direction, then the motor does not rotate in the forward direction. Like that, we can provide the interlocks here. That the CR017 output line, we place the CR18, and CR018 output line, we place the CR17 in order to make the mutual interlocks. In order to make the mutual interlocks. And this is the connection diagram. So here, how many inputs we have? Stop button, one start button for the forward direction, and one stop button for the one start button for the reverse direction. So what are the outputs? Forward direction, reverse direction. So the program which we discussed in the previous slide in this ride will be appeared in the PLC CPU, and for that PLC CPU, one side we have the input module, and one side we have the output module. So the input module will be connected to the input devices, and output module is connected to the output devices. And what are the input devices? Means stop button, forward start, reverse start. And what are the output devices? Means forward and reverse. And the next example is forward reverse stop, like that in the previous example, but here direct reversal. But here direct reversal. What is meant by direct reversal? Means when we press the start button of the forward direction, when we press the start button of the forward direction IN002, at that instant only the reverse direction will be cancelled. That means when the IN002 is on, the this contact IN002 is initially normally open. When it is make as on, then it will be acts as a closed one. So because of this closed path, CR017 is on. So because of the CR017, the motor will be rotates in the forward direction. When the motor will be rotates in the forward direction, some red light will be appear. Some red light will be appear. And similarly, when the IN002 is on, at that case, here we have the normally closed contact. So when this IN002 is on, so this normally closed contact can be acts as a normally open contact. So this entire line will be off position, in off position. That means when the motor rotates in the forward direction, there is no possibility of rotating reverse direction, and the forward direction can be represented with one red light. One red light. And similarly, in order to rotate our motor in the reverse direction, we have to press the IN004. So when the IN004 contact is on, then this normally open contact can be acts as a closed contact. Then we have to provide one path for the output CR018. So when the CR018 is on, then the motor will be rotated in the reverse direction. So when the motor will be rotated in the reverse direction, so the CR018 is closed path. So because of this CR018, the CR020 is on, which indicates the green light representation. Green light representation. So here the CR019 represents the red light indication and CR020 indicates the green light indication. So when we press the IN004, then directly this IN004 is also on. So this IN004 contact is a normally closed contact. So when we make it as on, then this normally closed contact can be acts as a open contact. So because of this open contact, the CR017 appearance possibility is not possible. Is not possible. So when the motor rotates in the reverse direction, then there is no possibility for the forward direction, and that reverse direction can be indicated by the green light. And this indicates the connection diagram for this example. So this entire program will be present in the PLC CPU, and for the PLC CPU, one side we have the input modules, and another side we have the output modules. So input module is connected to the input devices, and output modules are connected to the output devices. So here, instead of the output devices, we have another two extra representations. That means the forward direction can be represented with the red light, and the reverse direction can be represented with the green light. So those are also indicated at the outputs of the output modules. And next, start to stop jog. Start to stop jog. That means here the IN002 is for the running condition, and IN001 is for the stop condition, and IN003 is for the jog condition. That means what is meant by jog means for momentarily on of the output is called jog. So if we press the IN002, this one is a normally open contact. When we press the IN002, this one we acts as a normally closed contact. Then we can provide the one path for the output CR010. When CR010 is on, then this will be on. Then CR17 will be on. So when the CR17 will be on, so this will be closed, this will be closed. And even though we remove the IN002 switch, then the motor will be rotated in a continuous manner. And suppose if you want to run the only output for a moment, what we do means we can make the stop the total program. That means by pressing the IN002, we can stop the total program. Now there is no running switch. The motor will be stopped. At this time, we want to stop the for a moment of time. We want to stop. So for that reason, what we do means we can on the IN003. When IN003 is on, then this can be acts as a normally closed contact. So we can provide the path. So only CR17 will be on. Only CR17 will be on. So this IN003 can be used for the momentarily on of the output. Momentarily on of the output. This IN002 is the running input for the output. So this example gives the start stop jog circuit, and we already known about the connection diagram, representation of the connection diagram. So the inputs have start button, stop button, and jog button, and output is only motor. So that is previous ladder diagram will be inserted in the PLC CPU. That PLC CPU consisting of one side input module and another side output module. Input devices, that means stop button, start button, and jog button are connected to the input modules, and the motor is connected to the output module. This one is the fifth example. And next, sixth example. So what is the sixth example? Let us see. An alarm system operates as follows. That means totally we have four switches, four inputs. So if one input is on, nothing happen. If you on the only one input at a time, then nothing to be happen. And if two inputs are on, red light goes on. If the three inputs are on, alarm sounds. If all four inputs are on, then fire department alarm on. That means this is for the safety purpose in a industry. Safety purpose in a industry. So only one input is on means the severity of the fire accident is not that much of consideration. And two inputs are means the severity of the fire accidents will be somewhat considerable. And three inputs are means this will be caused to some dangerous position. And if the all four inputs are on means the fire accident will be very severe. So for that purpose, we have the some alarm siren and fire department notification. Like that, we have the outputs. So here we have the four inputs. Four inputs. Why? Because four inputs are on. So those four inputs can be represented with IN001, IN002, and IN003, and IN004. So if one input is on, nothing to be happen. So we cannot consider that nothing to be happen as the one output. And if two inputs are on, red pilot light will be goes on. So we can consider that red pilot light as the one of the output. And if the three inputs are on means one alarm sound will be ringing. So that can be considered as the CR018. And next, if all four inputs are on means fire department will be notified. So that can be considered as the 0 to 19. That means here we have four inputs and three outputs. So what are the four inputs means? If two inputs are on, any two inputs are on, any two inputs are on means two inputs means we have to represent those contacts in series manner. And any of the, if you get the any of, then those combinations definitely we can represent in parallel manner. So totally we have four inputs: IN001, IN002, and IN003, and IN004. So these four inputs, how we can arrange two ways. First 1 2 and 1 3 and 1 4 and 2 3, 2 4 and 3 4. Like that, every two combinations we can make as six combinations. Two inputs at a time we can form as six combinations. So all these six combinations are we have to connect it in parallel manner. In every situation we have to use two contacts. That's why we connect two contacts as in series manner. So IN001 and IN002, IN001 and IN003, and IN001 and IN004, and IN002 and IN003, and IN002 and IN004, and IN003 and IN004. So whatever the combination will be on, the CR017 will be on. That is nothing but red pilot light will be on. And next, if any three inputs are on, that means how many possible combinations we will get? 1 2 3, 1 2 4, 1 3 4, 1 2 3 4. Four combinations we will get. So in every combination we can represent the three contacts, and like that we have the four possible combinations. So these all four combinations we can represent in parallel manner. So any of these four combinations will be on, then the siren will be on. So the siren will output can be represented as CR018. CR018. If all inputs are on, then fire department alarm will be on. So all inputs means only one combination: 1 2 3 4. So 1 2 3 are connected in series, and this will be fire department alarm representation. So this entire program will be present in the PLC CPU, and for this PLC CPU, one side we have the input contacts, and another side we have input modules, and another side we have the output modules. So input modules are connected to the input devices. So here we have the input devices are IN001, IN002, and IN003, and IN004. So four inputs, and outputs are three ways: siren light, siren, and red light, and fire department. So these output devices are connected to the output modules. So these are the six examples which illustrates the use of contacts and coils. So in every example we have how we can use the contacts and how we can use the coils. So one more example is there. That is nothing but drill press operation. So in that example we will see the how we can make a hole to a particular object. So that will be explained in the next video. Thank you.